Good day, dear listener. I am Aziz Latif today with registration number TP 23/24 H/1222. So today I'll be making a presentation on um, my lesson learned from the report Appraisal of riser concepts for Fpso in Deepwater. Before I go, what is an Fpso? An Fpso is a floating uh, floating platform storage and offloading, floating production storage and offloading platform. So, and the use of deployment or development of an Fpso in deepwater requires um, a well advanced or materialized risers. In this report, we look critically into the kind of um, things to put into considerations and how these risers are being developed, considering their environmental factors and other conditions necessary that are associated with deep water. So here is the outline. So moving from the introduction to overview of yeah, then this slide we look into the development of seawater field as global oil and gas is advancing. It actually requires that the development of a complex engineering problem. And what are these complex engineering problems? One of them with this report is the riser system. This riser system is used for transporting hydrocarbon from the seabed. But now that it is operating in deep water environment, it is now contended with high hydrostatic pressure from the deep water, and it requires significant dynamic motions and offsetting. So for our risers to sustain all of these challenges, it needs to be critically assessed and use all the right technology. And so I did a comprehensive overview and a detailed discussion on the following, and one, deepwater riser concepts. That's what I make a critical research on that. What are they and what are the different concepts that we have? I make researches on component of a floating production system. Just as I said, I made reference to Fpso, but we have more than Fpso as the floating production system. We have tension legs, we have semi-submersible, and we have SPA. So they are all floating production system. So I look at the riser concept based on their configuration, construction, dynamic performance, and design analysis. And and I analyze the current trend and the future of riser concepts, and also identify the existing technology gap. So, and as I said from my overview, that the floating production system is more than just Fpso. We have Fpso, we use it in a, that's what I learned, in remote field. And it used to lack, pipe infrastructure. So the remote field that lacks pipe infrastructure rather. And semi-submersible is used significantly in harsh environments with significant payload requirements. Tensionless, it has dry trace operations and well-controlled motion, while SPA is used in moderate environments and its capacity is moderate, is moderate too. So what are some global historical records? I've critically put two down, one of which is offshore Brazil. It was the first place to use free hanging flexible riser, which allowed the field to handle large vessels without any fatigue consequences. Another thing is the Gulf of Mexico. This was the first field where steel catenary risers are used in Deepwater. So it was a milestone in 1994, and that milestone made them a template for over 100 similar development that we have in the present day. So what are the current trends? There's no current trend in my research other than material advancement, and technology. That's what I discovered. Now, number one is the adoption of advanced material, where engineers and scientists, researchers are thinking of using light composite material to design and develop risers. A composite, flexible and light in weight. So, and materials that are, that can sense environmental changes and respond by themselves. These are trends that are going on in the field. Another critical trending is the digitalized real-life monitoring. So when you don't have to be checking your computer often and often, but you program the system and it gives you continuous monitoring reports of what is going on beneath the sea, along the risers and the likes. So, and there is this technology called digital twin technology that creates a virtual replica of physical riser system, or a digital that allow engineers to stimulate and predict what the behaviors and various operation conditions. So basically, this is what I concluded on, that the selection of deepwater riser for an Fpso is complex, really complex, because it requires multivariable engineering programs and true appraisal of technology and environment, so we can factor that in. So in short, why conventional SRS is simple and cost efficiency, dynamic environment required at the driving development of advanced solution for more advanced solution. Thank you very much for the audience. I appreciate. Thank you.